Hi and welcome back everybody. Sorry I took a couple days off, but I was not feeling well. But thankfully, after some rest and some Tylenol, feeling a lot better now. Hope everyone is staying safe and healthy out there. I had a question in chemistry about balancing chemical equations. Now, chemistry kind of builds up on itself. You have to learn the nomenclature. They might give you the words and of an equation, then you have to put that into its formulas, and then we have to balance the equation, because after you balance the equation, that's when we can start doing the math problems. It's called stoichiometry, like figuring out how much of one compound will come out when you put a certain amount of a different compound in. So I think the first one that we'll go over is a combustion reaction. So a lot of students find this one kind of easy to memorize. It's some sort of hydrocarbon, so carbon and hydrogen, plus oxygen will always give you carbon dioxide and water. So oxygen is always O2. So let's this is the general formula for a combustion reaction. There's always oxygen is used, and then carbon dioxide and water are always the products. So let's do the first example. Let's say propane, right? Something in your combusts in oxygen. Okay, so propane, right? Your backyard grill is getting fired up. So we want to know, well, first we need to know what propane is. And this is more of a AP Chem thing to memorize, but it goes methane, ethane, propane, then butane. And then we start getting into the pent, hex, ... So meth would be 1 carbon, ethane is 2, propane is 3, butane is 4 carbons, pentane is 5, hexane is 6, and so on. So we want propane, so that's C3H. So propane combusts in oxygen, so C3. And then how many hydrogens? Well, H8. That's just something that we can look up. If you wanted to know what propane is, it's C3H8. And it combusts in oxygen, so we're going to add oxygen. And like I said, the products are always carbon dioxide and water. Okay? Now, this is how I like to balance equations, and I think this will be very useful for all of you. CHO. So I'm listing all of the elements that are on each side. Well, there's carbon, hydrogen, and oxygen. When you write combustion reactions, it's going to be the carbon, hydrogen, and then oxygen. So write it in that order, because carbon, if you write it in this order, it's going to be the easiest to balance. Saving oxygen, saving this oxygen, the number that goes here, for last. So carbons, there's 3 carbons over here, and there's only 1 over here. So I can't just put a 3 down here, because that would be too many. That would change what this compound is. Carbon dioxide is CO2. Okay, it looks like this. CO2. Well, we need 3 of those entire molecules. So there's 3 carbons. Now there's 3 carbons. Now hydrogens, there's 8 over here. Well, there's 8 over here. How many are on the right? Well, there's 2. I can't just change that to an 8. I need to somehow make 8 hydrogens. Well, there's 2 hydrogens for every water molecule, so I need 4 of them, because 4 times 4 water molecules would give me 8 hydrogens total. Now, like I said, saving oxygen for last, this will be the most helpful. So there's how many oxygens on this side? Well, there's 2. But let's look at this side. There's 3 times 2, that's 8. Sorry, there's 6 oxygens on this side, plus another 4. So there's 10 total oxygens. This is why it's easy to save this oxygen for last. Well, if there's 10 on this side, I don't want to put a 10 here. What do I want to put? Right, I want to put a 5, because for every oxygen molecule, there is 2 oxygens. So I need 5 times 2, there's 10. All right, so just checking 3 and 3, 8 and 8, 10 and 10. This is your balanced equation. Now, normally, gas, you have to put the states of matter, liquid, okay? So it's implied, you don't have to put a 1 here, but it's implied. There's a 1 propane plus 5 oxygens will create 3 carbon dioxides and 4 waters. Okay? That's a combustion reaction. That's kind of a special one. You always use C first, H second, and oxygen last. But now let's look at another type of reaction. Let's do phosphorus. Let's write it in letters here. So phosphorus pentachloride, and let's do water. Make phosphoric acid and hydrochloric acid. Hydrochloric acid. Okay, phosphorus, let's get focus here. Phosphorus pentachloride and water make phosphoric acid and hydrochloric acid. So let's figure out first what these are. Phosphorus pentachloride. Well, phosphorus is just P, and chloride is Cl, but we have penta. Think pentagon, right? There's 5 chlorines. Then we're adding it to water. And then we make phosphoric acid. So remember, 8-ic, itis, meaning we have phosphoric, so it has to come from phosphate. Phosphate is PO4 and has a -3 charge. So PO4. If that has a -3 charge, how many positive hydrogens do we need? We need 3 of them. Then we're making hydrochloric acid. I know it's ends in ic, but if you have a hydro, that means it's not the polyatomic ion, it's just HCl. It's just the chlorine, like hydrobromic is HBr, hydroiodic. If it starts with hydro, it's just those elements by itself. So this is our unbalanced reaction. So let's take a look at how we can balance this. So this is a trial and error process. Let's see, we have phosphorus, chlorines, hydrogens, and oxygens. Phosphorus, chlorines, hydrogen, and oxygen. So I'm going to use a pencil for this because it's going to take a little bit of erasing if we don't get it right. So there's one phosphorus, and there's 5 chlorines over here. So we need 5 of these, 5 HCl's, because that'll be 5 chlorines. So that makes 5. Now how many hydrogens are there? Well, there's 5 and another 3. There's 8 hydrogens total, because 5 H's and then 3 of them right here. So we've got 8 over here. So that means how many of these do we need? All right, we need 4. And let's just see if that, let's see, hydrogens, 8, there's 8. Now oxygens, well, there's 4 oxygens here, and then there's O4, so there's 4 oxygens here. So that should work. 1 and 1, 5 and 5, 8 and 8, 4 and 4. All right, so I think it's a really good way just to write out all the elements on each side with a line down the middle, and they have to match. Sometimes, let's say there was like 3 oxygens over here and 4 over here. You have to double everything if there's an odd number and an even number. So luckily this one worked out pretty well, but it's a learning process. It takes some trial and error, but hopefully after you do a bunch of these examples, you'll be able to balance the equation pretty quickly, because then we're going to start working on, once you have the coefficients, the 1, 4, 1, and 5, then you can start moving on to stoichiometry, where we'll see, like, if I had some phosphorus pentachloride, how much phosphoric acid will I make? That's going to be in the next section, but hopefully this helps with balancing reactions. Again, we started with a combustion reaction, and then moving on. This is not really, I guess you could call it a double replacement, but it's more of a synthesis of, we're creating 2 different kinds of acid from an ionic compound and water. All right, so I hope it helps, and keep on coming with those good questions. Have a great day.